This video is going to expand on our knowledge of multiplying polynomials. So more distributive properties, but with exponent laws. Okay, a polynomial one term is called a monomial. Examples of this could be just like 2x, that's one monomial. A polynomial with two terms is called a binomial. So for example, I could have 2x plus 1. These are different terms. They're not like terms. A polynomial with three terms is called a trinomial. So that would be 2x, for example, squared. That's 1. This is another term, 2x, and then 1. These are all three different terms that we cannot collect because they're different values. They're different terms. They're not like. So we're going to learn how to multiply two monomials. So 3 times 2x, we've seen this previously. This is just 3 times the 2, which is 6, and it's still 6x's. Now we have to use our exponent laws. So this is 3 times 2, which is 6. And then add the exponents because we're multiplying with the same base. X times x, when you have the same base, you add the exponents. So 1 plus 1 is 2. So it becomes 6x squared. Here, 4 times 5, that's 20. Number times the number. And then add the exponents. I have a 1 and a 1. That becomes x squared. Adding the exponents as per the exponent law. When you have the same base, you add the exponents. Okay. To multiply two monomials such as 4x squared and negative 6x, you multiply the coefficients. 4 times negative 6 is negative 20. So for 4 times negative 6. Okay. And you multiply the variables. So x squared and x. So 4 times negative 6, that becomes negative 24. And then when you multiply the coefficients, the variables, x and x, you add the exponents. That's the 2, and that's an imaginary 1. 2 plus 1 becomes 3. So let's look at some more examples. Here. So 4 times 3, multiply the number by the number, that's 12. Here there's an imaginary 1, so same base, x and x, 1 and 2, that's 3. So adding the exponent. Here there's an imaginary 1, so 1 times 3 is 3. Then add the exponent. There's a 1 on this exponent. 1 plus 2 is 3. Numbers by numbers, variables by variables. Negative 3 times 12 is positive 36. 1 on this x, 2 on this x. 1 plus 2 is 3. So x cubed. Okay. Negative 1, so there's an imaginary 1 there, times 6, negative 6. Imaginary 1 on there, 1 on this one, 3 on that x. That becomes x to the exponent 4. We can do this one in steps. So let's work on the first two first. 2 times negative 3, negative 6. Add the exponent here. There's a 1 and a 1. That's squared. I'm going to still write the other one down that I haven't worked with yet. Okay, so that one's that. And now I'm going to do the next two. Negative 6 times negative 6. 6 times 6 is 36. Positive because it's negative times negative, and then add the exponents. 2 plus 2 is 4. So now we have the product of a polynomial and a monomial. So here we have a binomial and a monomial, so one term. So I'm going to multiply the expand. If you recall from previously, means to In other words, means to multiply. So expand the following, multiply. So remember your distributive, 2 times x is 2x, and then 2 times 3 is 6. Here, multiply this 2x times x, that's 2x squared, and this 2x times 3, which is 6x. Negative 3x times 2x, so first multiply the number by the number, so I get negative 6. And I know x times x is x squared. And I'm adding the exponents 1 and 1. And here I'm going to multiply the negative 3 times 5. Negative 3 times 5 is negative 15, but I still have the x there. So that's a monomial times a binomial. Now we're looking at monomial times a trinomial. So again, still distributive property when there's a monomial outside of a bracket. Negative 2 times 3 is negative 6. X and x squared is x cubed. Negative 2 times 4 is 8. Whoops. That should be a negative 8 because it's negative times a positive. Add the exponents, 1 here, that becomes squared. Negative 2 times negative 7 is positive 14, and it's x. Here's another example, negative x times x cubed. Remember, that's a negative 1 and a positive 1 in front of there, so that becomes negative. And then there's an imaginary 1 here that I'm adding to that 3 on the x exponent, so that's a 4. Negative times a negative becomes a positive 2. 1 here, that's squared. And then negative times a negative is positive 6. And we still have an x there. It takes a lot of practice to get the hang of these. So remember, what we're doing is we're multiplying the numbers by the numbers. And because they are the same bases, in other words, they're all x's that we've been working with, we can add the exponents when we multiply them. Okay, in example 4 says find an expression in expanded form. So it wants me to multiply when it says expanded. For the area, so we're talking about area of the given rectangle. So I'm going to do part A first. If you recall, area of a rectangle is length times width. Okay. So I'm going to take 3x as my length and 2x plus 15. So that's an expression. But it wants it in expanded form. So I'm going to expand. I'm going to multiply. So 3x times 2x is distributive property. 3 times 2 is 6. And then add the exponents. There's a 1 there and a 1 there. That becomes 6x squared. Then do 3x times 5. 3 times 5 is 15. And it's x because this. So that's my A. So let's just make sure I answered it. Find an expression in expanded form. Check. For the area, I did area of the given rectangle. Part B, let's see what it needs. Find the area of the rectangle and x is 5. So suddenly now I know x is 5. So if x is 5, you take your expanded equation and sum in 5. Wherever you see the x, you're going to plug in 5. Okay. So I plugged in a 5 there. And I plugged in a 5 here. So now I'm going to do my order of operations. 5 squared is 25. And then 15 times 5 is 75. 6 times 25 is, so you noticed I did my exponents before I did any multiplication. And then I multiply before I add. I'm following BEDMAS. And this is 225. When we have a unit, we have to include it. This is centimeters, and because it's area, it's squared. So the area of this rectangle when x is 5 is 225 centimeters.